Okay, so in this video they have been giving you a .cv file. Okay, in this particular question, where is the question? This question. And this command, when you run this command, it will show you this. It says that you have to overflow the buffer. This is the buffer stack they have given you, so it has so many values, and you have to overflow this value till you get to this point. Okay, correct answer, correct secret. So if you overflow it to these many characters, that means if you buffer or overflow these many characters, you are done. Okay, you are literally done. And then you should see that this red thingy basically implies correct. Okay, correct secret. So that means that this has something to related with correct, okay, or secret. Now if you open this file in your mouse pad, which I just did, this is over here, not here, which I just did. Where is it? Is it gone? Okay, here. So you can see that the correct stuff is here. Okay, here, if the secret is equal to this thing. So what we just need to do is we just need to copy this and control C this, control Z, sorry, my bad, copy, paste your hex input here and convert this, and it says gandalf. You will just copy the selection over here and then buffer overflow this to this point, and to buffer overflow this to this point you have to input some text, and that would be control C, that would be see, this is basically 1, 2, 3, 4, 5, 6, 7. Where these are 6 rows right here, right? And these are 8 columns, so you need to have say 48 A's. So what we'll do is we will actually control C this again, and we will write print Python, sorry, Python 3 print a course, say this is 6 into 8, which is 48 A's, so you will print 48 A's. It says cannot open file, okay, my bad. And then open file, print what? Where? Wait a minute. Okay, so this was that you need to write here #c, #c, and then to add a colon here and here as well, and then it should work. But ultimately it doesn't, so maybe it's interpreting this as this, so what we'll do is we'll just press enter. So yeah, this is giving you the number of A's 48 times. Copy this out and run your command, and do this thing. I mean, paste a selection and write the one graph. You overflow the secret value. It says now you overflow the secret value, now try controlling it. How do you try controlling it? Now that this is you overflowed the secret value, you have to try controlling it. So what we'll do is we will just run this particular command again, and we will paste the selection and write graph. Now I don't know how to control this. Okay, so the thing is that you have written graph here, but it's a stack, so the stack works on last in first out principle. So that means that you would particularly have to write this A here, right here, and flag here, not flag. We write small flag. Okay. So it says maybe you're through too much. Yeah. So maybe I overflow too much. I run this again. We will print, paste this text, and shift this A. I'm not very good at this, so I'm sorry. And then we write flag here. Wow, you have overflowed. That's what I did. Right? That's what I did, bro. It's the exact same thing I'm doing. Okay, now it shows that you have successfully did it, and buffer overflows are cool. So this sample is something related to buffer overflow. Just copy this out and paste this here. I again remind you that this is not something where I spend my time learning. I just want to cover as most if I can by. Okay, so this easy challenge took me like so much of time, and then let's go to our challenges and go to the next one, which is, let's go to forensics one, and let's go to PDF by let's just make sure it's recording. fdpumyp, something like that. Hi, as we talked during a break, you have this file here, and check if something is wrong with it. Wait a minute, just close the door. So we are back. So this says, as just as we talked during a break, you have this file here, and check if something is wrong with it. That's the only thing we found strange with this object. So the suspect, I hope there will be a password for his external drive. Bye. So he just wants to ask. He just wants to check this file. He just wants to check this file out here, and check if something is wrong with it. So we'll just download this file. The file, okay. And it is not .open.pdf, but we are gonna open it. Basically, hackers open stuff which are not allowed to open. So we're gonna open it. So we're gonna open it right here. Wait, let me see. We're gonna open it in our command prompt. Where goes my command prompt? Where does it go? Okay, so there you have. So we will open it. We'll do a cat command on don't, or we can just write eog. eog don't open.pdf. Okay. Could not load image don't open.pdf. Maybe this not an image. We can do a cat command don't open.pdf. Okay, so this is the password here. They've also given you a pin, so maybe you can try. This is base 64. Maybe you can try converting this from base 64 to something. This is base 64 decode, and we will paste this text here. Try to decode this stuff here. Just decode, bro. Okay, it says 1231 wrong 9js something. If you see this is external, and this is also. So what we'll do for now is we'll just copy this stuff here and paste this somewhere here for now. And we have this particular stuff as well. So just copy this out, and so what we did in here is, in this question is, think the flag is somewhere in there, would you help me find it? So what we did is basically did exif tool command on this image and found that the keyword is the password here, the passphrase is myadmin, and then there was this particular weird looking number which I didn't go into. I just write stack hide hash info menus.jpg, and it said that do you want to get some information about embedded data. I said yes. So then I enter the passphrase, which was myadmin. It says that there is an embedded file in this and it is encrypted. Okay, so it is encrypted means you had to write the password to view it, right? After that, what we did is we just extracted that data using this particular command here, stack hide extract sf menus1.jpg. We enter the password, so it wrote the extracted data to this particular file, and then we cat the file. After that, we read this particular image, and this is base64, and then we convert that base64 to this particular flag. That's it. That's all you had to do. Okay, that's all you had to do. Okay, so there is this image gandalf.jpg, and we have found that this is intense. If you want to get info about this, you have to enter a passphrase. So if you try to convert this over here, over here, when you convert this, it says using base64, it says that, wait, let me show you. So if you use base64 here, and try to convert, this is city of Lawrence, or is your friend, and this is not your flag. This is not your flag, and I have tried running it, and it shows that it's a wrong flag. Maybe you can try removing the underscores, because you never know. Okay. You never know. So it is not the right way of doing it. Okay, so what do we have to do here is basically use the string command on this thing. That's the only thing which we didn't do. So we use the strings command here with this particular image, gandalf jpg, and see that there are a number of strings. We will scroll all the way up to see our three main strings, which are these. Okay, so these are the three main strings. This one we have already decoded, and it says Zor is your friend. That means it's giving something that we have to Zor, we have to Zor. So we have to take this particular value over here. Okay, control C this, copy this thing, and paste this here. Okay, that shows a very weird answer. So what we'll do is we will convert base64 to hex. Okay, so you want to convert a base64 message to hexadecimal. This is our base64. Convert base64 to hex. And when you convert base64 to hex, you will see something like this. Okay, so just copy this out and paste this here. This is your first hex value. This is your second hex value. Paste in here and convert base64 to hex. This is giving you this value. Control C this and control V this. Okay, now we want to use a Zor calculator here. So our first input is this. Control C, Control V, that's a very big output. Okay, Control Z, Control V. That's a very big output, sorry, input. And then we give this over here, calculator. When you calculate your, the output is something this. You need to convert this hexadecimal back to X key, so you write asterisk key, hex to X ASCII. Doesn't work. Why is my computer? Okay, so there we go. We will drop the hexadecimal, and there we go. We have the flag. Okay, so this is the vertical flag we were looking for. This was not the flag. This is a false flag. Control V this and submit. Okay, so this challenge was to be done like this. We will go to the next challenge. This is the last challenge, easy challenge for the day. The last one for the day in their easy category. Let's do something else. Let's do reverse engineering. Okay, let's do something with reverse engineering. It's really fun, believe me, it's really fun. Just taking your time until that we will pause it. So this challenge is called Reykjavik, and I have no idea what Reykjavik is. So, I mean, this looks like a weird name. I have no idea what reverse engineering CTFs are. This is my first one, so I'll just. It says good beginning reverse challenge. Jump into the GDB and start looking for the flag. So in most of the cases, they will give you a zip file. In reverse engineering challenges, they'll give you an exe file or a zip file or something. I have no idea what to do in this, how to start, so I will just copy this and look for it. I'll be right back and explain you what is happening.
Build extremely complex front ends driven by basic concepts and
this dude makes good videos. You just see his video on this one. Okay, this dude's name is Almond Force. Okay.
Hello world, welcome back to another CTF Learn Challenge video. In this video, we're going to be solving Reykjavik. Let's get into it. So this is a reverse engineering challenge, and it is worth 10 points.
Okay, this is
Good beginning reversing challenge. Jump into GDB and start looking for the flag. Now there's multiple softwares we could use to solve this, but we will be using GDB to solve this as the challenge suggests. GDB is pretty much the oldest reversing tool out.
Okay, so I had no idea on how do you go about doing this, but this guy told me that if this is the challenge, then you basically have to unzip this folder into somewhere and go to the directory, and you have to basically get something known as GDB Pera. It's a tool, it's a Kali tool, which is, I guess, might be helpful for disassembling effectively. So I just did that. I just downloaded the tool, and I'm running this tool right now. So this is how we are supposed to use this command. This you will get it in the strings. So when you run the strings command with the file, you will get how to use the GDB command. I say use command with this file name. Okay, so this is how you do it, and you run the program after this, and then you see that sorry dude, CTF learn is not the flag. So what you do is you start the program, you start debugging, and this will debug to main, so debug up to main. So then you are gonna set a breakpoint at something where you had an str compare function. So if you see an str compare functions, if you debug this file, you will see that this function using a cutter tool, you will see that it will return the flag if there's some kind of string comparison. It results in true. That means the string comparison results in 0. So the string comparison is okay. So the string comparison is happening here again at this ID. So you get this ID and set a breakpoint by using this particular command of beta. So you're setting a breakpoint using b keyword, and then you give an extract, and then this address. So breakpoint to add this address. Then you run the program, and when you run the program, you basically get this flag over here. So this is the flag which we needed. So I had no idea about this. I looked into the video, and this is what he said. Okay, so just thank you for watching.